So null safety.
I was checking your repo just this week. I was reading
Which repo?
the null safety plugin.
Oh yeah. So what is a null pointer or null reference? Is it a value or a non-value? Is it a value of a non-value, or is it something else? As said by the inventor of the null pointer, it's his billion-dollar mistake. This has led to innumerable errors, vulnerabilities, and system crashes, which have probably caused $1 billion of pain and damage in the last 40 years.
So it's a great thing, essentially. It's a great idea.
It's a very great idea.
It keeps us employed.
Yes.
That's one way to look at it.
And now, if you use a language with a static typing, which Hux is it safe to invoke a substr or to uppercase on a string? The type system promises you can do it, but in fact sometimes it will crash your program. Because that string can happen to be null, and null doesn't have any fields or methods. That brings some dynamic feeling, and I recall a PHP every time I hit a null pointer error. So the null pointer error is the most common error. I will not go into details about all the troubles caused by a null reference, but I can show you how many suffering it caused to the GitHub users. For that purpose, I searched for commits by the strings like fix null reference, fix npe, fix null pointer, and got over 11 million results. If we pretend that every commit took about 2 minutes, which is obviously a very low estimate. It's a total of over 40 years of non-stop work. And it keeps growing every day, every second. I think even a murderer gets less brutal punishment. So what do we have in Hux to... Oh yeah, that's funny. Because humanity spent tens of years fixing null pointers, and it's only judging by a GitHub, but there's always those private repos, code in production. I think it's more like hundreds of years spent on fixing null pointer errors. So what Hux has to offer to protect ourselves, and that's almost nothing, at least out of the box. We have that special abstract type, null of t, which can be used to document places which accept or produce null values. And the only real thing that this abstract does is it's boxing basic values on static platforms. Sure, you can use it to hint nullable values and keep checking manually for null, trying to not forget, but are you disciplined enough to do it every time you use nullable value? And what about the other developers on your team, or maybe that guy who created an awesome library you use in your project? So let's check this code. At the first sight, it's the safe code which will not crash your program if supplied with a null value as an argument. But in fact, it's a very vengeful code. The signature of this method does not null type hints, so it kindly asks you to not supply null, and it promises it will not return you a null value. But if you ignore this contract and provide a null instead of an object, this code will screw you up by returning a null value back to you. And now you have an unexploded bomb floating through your program, waiting for the best moment to crash it. Probably the developer who wrote this thought that he did a good job avoiding a null pointer. By the way, I also wrote the code like that, but forgot or was too lazy to type hinted with null of t, and now you have a problem. It's a code from the standard hex library, by the way. This code is from the JavaScript target, but PHP target has it as well. Another option is a hex.ds option type. If you have a variable of option type, then the compiler won't let you use the value until you make sure the value exists. But it adds an overhead at runtime because it boxes any value stored in an option, not just basic values as null of t does. And also, xds option can be null itself, and the boxed value still can be null. So you have two possible null pointers instead of one. It's like that old joke on the internet. Some people, when confronted with this problem, think, I know, I'll use xds option, and now they have two problems. So the third approach was taken from the Hex cookbook. I think that's Mark wrote it, or maybe Nadeko. Yeah. It's pretty nice. This abstract makes you check for null before you could actually use a value. It does not carry an overhead in runtime like xds option. However, it makes you write excessive null checks because not only exists check for null, but also sure and other methods check for null before performing any action. And if you have several variables with the maybe, your code may become to look like closure hell in JavaScript if you use methods like may, which needs a closure. But the most important is that the absence of maybe in a type hint does not mean the value cannot be null. So it's back to you, to how disciplined you are. Now, what we could have if the hex compiler supports null safety. Instead of maybe and null of t and what it had, hex.ds option, we could give some meaning to the null of t. The compiler could prohibit passing nullable values to non-nullable places without a null check. The previous slide shows the errors which could be produced at compile time, and this slide shows how to fix the code. You just need to check for a null, and you need to type hint the return type with a null, so the compiler knows that you are aware you are working with a null value. This approach is much better than maybe because it gives you a promise that if a value has no null type hinting, then it could not be a null pointer. But also null safety has some drawbacks. For example, if you usually don't care about safety or any errors when you just assembling a simple script to do some dirty job on your file system or anything else, or if you're trying some crazy idea on the try hacks, then null safety can be really annoying with its errors. Also, sometimes null safety makes you check for null even if you are 100% sure that there is no null value. Like in this example with iterating through a map. That's the only drawbacks I can imagine. Maybe someone else could find more. So what troubles do we have on the way to null safety in the compiler? That's the array. First of all, it's an array specification. Out of bounds array reading always returns null, but it's typed without the null type hint, so that even if compiler support null safety, it cannot check array access for safety, and it makes something like a type hole in null safety. Also, array writing out of makes a trouble, because if you write a value outside of an array bounds, the gaps is filled with null values, and then again reading an item from such a gap will be typed without the null type hint, and the compiler won't be able to check safety here. The other are not really a null safety violation, but it could be annoying that map API doesn't have a way to read the value without making it nullable. If you're iterating over the keys and getting a value, or just getting a value with a get method, it's always type hinted with null, and that makes you check for null every time, even if you are sure that the key exists, or you need to. No, that makes you check it. Yes. This problem could be solved with the new key value iteration syntax, but the key value iterator for maps, which was merged recently, was implemented as a shortcut for the old way of iterating over the keys and getting the value with the get method. Even worse, with the new syntax you will get the value without the null type hint. So when you or some other code remove a key from the map while you are iterating, you will get the null value without the hinting that it could be null, and the compiler cannot check this. The other problem is the legacy code created. What?
I would not do that with a map.
Well,
I'm pretty sure on some platforms it just crashes anyway. Not on
I never saw that crashes.
HL, I wouldn't be so sure.
I'm pretty sure users will do it, since it's possible to do. So the legacy code, you cannot just enable null safety for the code that already exists, because it was written without the null safety, and obviously will break your compilation. It will not make through the null safety checks. For example, building the standard library with the null safety enabled would produce over 800 errors, compilation errors. To avoid this problem, null safety could be implemented so that the user have to explicitly specify which packages should be checked for safety. That way your com.awesome.game package will be safe, while all the other standard library or the third-party libraries will not break your compilation and will keep working. And still, with such a solution, we will have some new code appear without the null safety enabled. We can't really do something with it from the compiler perspective, except for typing every outer code as nullable code, but that will be really annoying. So we should just fix it, submit issues, and pull requests. Now this one, not really an issue or a problem, but it's nice to have. It's safe navigation operator. Safe navigation operator may reduce the amount of code needed to deal with nullable values. It evaluates an expression to null if the left part is null, and if it's not, evaluates the whole expression just like an ordinary dot access. In hex we cannot have postfix question mark because it will introduce ambiguity with the ternary operator. However, we have some languages like C# and Perl where these operators coexist, so I hope at some point we could have postfix question mark too.
Nicolas said he's against it.
Yeah, I heard that, but he was
Oh, well.
he was against short lambdas for 5 or 6 years, so maybe in 10 years we will have postfix question mark.
Never give up. Never give up. Never give up.
Now, for over a year, there is a plugin support in the hex compiler. I don't think anyone actually used it except me. I have created the safety plugin which implements null safety and a couple of other features. Now I'll talk about those features. The main one is obviously null safety. The plugin allows you to enable null safety for specific packages. It controls the values which are type hinted with the null abstract. You won't be able to pass a nullable value to a non-nullable place until you make sure it's not a null but a value, thus making it impossible to get a null pointer error caused by the code under null safety control. Whoops, not this. Yep, this. The plugin also checks that non-nullable class fields either have default values or initialized in the constructor. You won't be able to use a field before it is initialized. This feature could also save your math on the platforms which has null or nan for uninitialized numeric fields. Also, sometimes you need to exclude a certain code from the safe area, maybe for better performance or something else, or if you're doing something crazy, I don't know. This feature just exists. Sometimes the plugin provides a safety meta which you can use to annotate fields, and those fields will not be checked for safety. Also, you can attach this meta to a class, and the class will be excluded from null safety. And there is a special type def unsafe of t. Any values passed to or from such type will not be checked for safety. Also, this type def allows you to disable safety check of an arbitrary expression using the type check syntax. The meta and the type def unsafe, you should not really use them. Think twice before you do it. And the safe navigation operator. Since we don't have the postfix question mark, but we have postfix exclamation mark, the safety plugin implements the safe navigation operator through the exclamation mark. If the left part of the expression is evaluated to null, then the right part is completely ignored and null is returned. If the left part is not null, then the whole expression is evaluated the same way as if there were no exclamation mark. And I managed to fix an issue with the code completion for such an implementation. Now it provides a normal code completion from the compiler. Another feature is safe array. It's required to solve the problem of the standard array specification of reading and writing out of bounds. So this abstract behaves exactly like an array, except the index access out of bounds. It will throw out of bounds exception. Using the compiler argument dash macro safety.saveArray, you can automatically change typing of all array declarations in a certain package to safe array.
I
So this Any question?
The slides are up? No?
What?
Maybe not.
That was.
You didn't talk about this one.
Oh, I missed. What? This was safe array.
Yeah.
Yes.
And that's the next. Yeah.
Okay. Safe API is the feature which could be useful with you if you're a library maintainer. You want to create a library which does not allow passing null values where you do not expect them. So this feature allows you to automatically check for null values for arguments of all public methods in a certain package. If you add this instruction to the extra params HXML of your library, then your API will stay safe.
Assuming that the user of the library has this plugin as well.
No, they don't need this plugin. This safe API feature is implemented as a build macro. It's really fast with the new macro interpreter, so I think it's okay. Also, safety plugin has some static extensions for convenience. It's mostly the same as the fields and methods of the maybe abstract. Sometimes you really need them when you need to access the value just one time and don't want to write an excessive if. That's pretty much all. So the small conclusion that despite the problems I mentioned in this talk, it's definitely possible to implement null safety. Whoops, sorry. I hope it's still working.
What about the maps? Is something about maps?
I'm thinking about implementing another key value iterator and putting it in a library, maybe. So it's definitely possible to avoid the problem with the maps with a custom iterator at this point, and maybe some static extensions which will additionally check if value exists when it got a null from the get. Something like that. Well, that's all. Any questions? Other?
That was quick.
Yeah, I thought it would be.
You said 40 minutes.
Yes,
You're
I
at
thought
20.
when I tried it for the first time, it was 40 minutes, and I thought in live when I'm worrying, that would be even more.
Worrying makes you fast.
So I guess the obvious question is, are we gonna move this to the compiler?
I'd like to move this to the compiler, especially after we got merged the key value syntax iteration.
Yeah.
So I think nothing more to wait.
Okay.
I have a question about the implementation actually. Does that re-implements the whole control flow tree?
No, it just goes through the expressions, and when it see the one expression is passed to another expression, assigned to another expression, it just checks type and all.
I mean, because it's like we already in the compiler we have this control flow graph. But
I really
should
didn't
probably
touch
do it for
control flow a lot in this.
okay.
It was just a simple checks on during the iterating. That's all.
I guess we
We have a break again.
Another coffee.
Another coffee break.
Yeah, we have lunch.